Hello. Today we're going to be talking about standard deviation, and this is another part of statistics that's important when we're looking at analyzing data and sets of data that we have. So our goal with standard deviation is to find the standard deviation and variance of a set of values to apply standard deviation and variance. So this is essential that we understand that the standard deviation is a measure of how far the numbers in a data set deviate from the mean. So when we look at measures of variation, they're not the same as measures of center. Previously, we had talked about some measures of center. Yesterday, you did some measures of center. When you're looking at mean, median, mode, that's telling you where the majority of your data are centered around. Not necessarily the middle of your data, like median, but where your data is centered. What values is it centered around? Measures of variation are different. So yesterday you studied range, which tells you how spread out your data is, and your interquartile range, which was the difference between your third and first quartile when you were drawing your box and whisker plots. So each of those two measures were measures of variation. And so that's an example of when we're talking about variation, how far your data varies, how far your data set deviates from whatever your mean is. It's talking about spread, how far it's spread out. Variance is a measure for that, and so is standard deviation. They tell you how far your data values deviate from your mean, how far they're spread out from your mean. And we have some more Greek letters. So we have this one here. It's called sigma. That's what we use to represent standard deviation. Okay. The other one is sigma squared. This is what we use to represent your variance. So when you see sigma, you should be thinking standard deviation. And when you see sigma squared, you should be thinking variance. Okay. Okay, so how in the world do we find standard deviation and variance? Well, there's a lovely formula with some symbols that we need to talk about. First of all, we talked about x bar representing mean. Okay, so that little symbol right there, that's x bar. Whenever you see that, we're talking about the mean or the average of your data set. Okay, the difference of x minus x bar, all that's saying is you're taking each value in your data set and subtracting the mean from it. So let's say the mean of your data is 10. Okay? And the data value that you're looking at is 15. That's x, your data value. So we would just do 15 minus 10, so x minus x bar equals 5. So that would be x minus x bar here. Okay? Next, we have the square of that difference. So whatever you get, positive or negative, you're going to square it. And in this case, we get 25. So please excuse my handwriting. It's real terrible, and it's probably not going to get much better. So just bear with me. All right, so next, finding the average or the mean of those squares. That is the variance. So to find the average of each of those squares, what we're going to do, this is a symbol, it's called a summation symbol. And what that tells us is that we're going to add up all of these, the square of those differences. Okay, so once you've squared it, this particular one, we did 15 minus the average, which was 10, to get 5. We squared it, we got 25. Let's say the next one, maybe we did, I don't know, 3 minus 10. 10 is always the same. That's our average, our mean, our x bar. That's not changing. Each of the data values those is different. So 3 minus 10, that gives us a negative 7. And then we're going to square that. That's a 2. That's a 2. And we get 49. So your squares are always going to be positive because we're squaring the whole number, including the negative sign. So 49, and we're going to add up 25 plus 49. That's what's happening here. When we're all done, we're going to divide by however many data values we had. In this case, we've only got 2 so far. Okay, this is how we find variance. X or excuse me, sigma squared. We're going to find standard deviation by taking the square root of that whole thing. Okay? So let's try some here. Okay, so your first example, we're going to find the mean, the average, the variance, and the standard deviation. So remember, variance is sigma squared, and standard deviation, that's sigma. You might want to follow along in your notes for this one. So here's our data, 6, 13, 12, 9, and 10. So for every problem you get like this in your assignment, what you're going to do is find the average, x bar, the mean. So we're going to add up 6 plus 13 plus 12 plus 9 plus 10. That's how we get 50. Okay? Let me see if I can type that. So x bar is going to be 6 plus 13 plus 12 plus 9 plus 10. That's how we got that 50. All right? Next, from that step, what you're going to do is divide it by 5 because we have 5 values that we're looking at, and we get 10. So my average here is 10. Every single time, x bar is 10. So this table that you're looking at, all they've done is they've put in the values for x. So 6 was the first data value, then 13, then 12, then 9, then 10, and they put x bar next to it so you can see what you're subtracting from each value. So we have 6 minus 10 is negative 4. That's where that first value came in there. And so all that means is that it's 4 below your mean, your average. 13 minus 10 is 3, 12 minus 10 is 2, 9 minus 10 is negative 1, and 10 minus 10 is 0. So this one's not above or below, it's exactly at 10. This one's 1 below, this one's 2 above, 3 above, and 4 below. And below your mean is what we're saying. Okay, so that's x minus x bar. That's what's going to go here. And then we're going to square it. So x minus x bar squared. So each of those values squared. So negative 4 squared is 16, 3 squared is 9, 2 squared is 4, negative 1 squared is 1, and 0 squared is 0. Okay, so we have x minus x bar squared. And that, remember, this is a summation. Summation means a sum. You add. You add all those x minus x bars together. Okay, so let's see if I can write that in. Right here, I'm going to type in what we're adding together. So we're going to add together 16 plus 9 plus 4 plus 1 plus 0. There we go. That's what's going right there. And I'll drag it over to where I put my arrow. Okay? Then when we add all those together, 16 plus 9 plus 4 plus 1, we get 30. And divide that by 5. That's how many total values we had. 1, 2, 3, 4, 5. And so your sigma squared, or your variance, is 6. Your variance is 6. All right. And that's telling you how spread out your data is. One that you're going to see, I think, a bit more often is standard deviation, especially once we get into normal distributions, which is to come. But your standard deviation, all you're going to do is take whatever you got for sigma squared, or your variance, and take the square root of that. So you're going to type this one in your calculator. 6 is not a perfect square. So the square root of 6 gives you approximately 2.4. So what that means is that we have a standard deviation of 2.4. Your data deviates about 2.4 from that mean. Not exactly, but about. And that looks to be about true if we subtract 2.4, if we add 2.4 from that 10, that mean. And we'll talk a little bit more about that in a minute. Okay, so if we were to do this on another data set, I would love, and if you need to rewind and see those equations again, that's fine, but I would love for you to pause me in a moment and work out the mean. Remember, that's x bar, and your sigma squared, that's your variance, for this data set, and your sigma is your standard deviation, okay? Your standard deviation. All right, so give me a pause. When you unpause me, I'll have answers here for you to check. Okay, hopefully you had a chance to run through that and type all those values in. So as you can see, I created a table here like we did in the first problem. You do not have to do this every time. I just like the visual that it gives you when you're trying to first learn this. So I listed all my x's, all the values here, all my data points, 8, 16, 12, 15, 4. I calculated my x bar, my mean, and I got 11. So all I did is I added them up and divided by 5. So my x bar here for every single one of these is going to be 11. So I just wrote that in. Then we did x minus x bar. So 8 minus 11, negative 3. 16 minus 11, negative, that should be positive 5. Quick fix. Okay. Then we did 12 minus 11 is 1. And 15 minus 11 is 4. And 4 minus 11 is negative 7. Okay, next up, we squared all those numbers. So negative 3 squared is 9, 5 squared is 25, 1 squared is 1, 4 squared is 16, and negative 7 squared is 49. So that was my x minus x bar squared. Now if you remember from the last problem, those were all the numbers that we added together from this equation right here. Okay, so we're going to add all those numbers just like we did in this problem. Okay, so we did 9 plus 25 plus 1 plus 16 plus 49. We got that summation. Then we divided that by however many numbers we had, which was 5. Okay, so I had 100 when I added those together, divided it by 5, and I got 20 for my variance. That's sigma squared. For sigma, my standard deviation, I'm going to take the square root of that number. Square root of 20 gives me about 4.5. That should be approximately equal to, I rounded that. So we have our x bar, our mean, our variance, sigma squared, and our standard deviation, sigma. So that's how we calculate all those values by hand. Okay, so next up, we could do the same thing when we have more numbers, just like we have here. You'd want to make sure you set it up. If you like this table, go ahead and do that. My hunch is that you'll get used to what you're supposed to do here after you find your mean, and you won't need that table anymore. Okay? Alright, so let's move on to a question like this. Determine the whole number of standard deviations that include all of the following data values. So what in the world does that mean? So here we have a whole number of standard deviations, including all of our data values. So again, what that's saying is whatever you get for your standard deviation, that's how far away we're moving from our center, from our mean. Okay, so here, if our mean is, let's read the problem. Your brother is buying his textbooks for his first semester of college. Yikes. The price of each of his books is shown in the table below. The mean of the data set is $65.85. So he's paying approximately $65.85 for a textbook. I hate to tell you guys this, but that is not very far off. As a matter of fact, that's a little low as far as textbook prices go. Anyway, so the standard deviation is about 36. Within how many standard deviations of the mean do all the prices fall? So basically what they're saying is we have our center here, and it's 65. Wow, use your imagination. That is rough handwriting. Okay, so it's $65.85, $65.85. So if the standard deviation is 36, what we're going to do, this would be like our center, and we're going to subtract 36 from 65.85 and see where we land. Okay, so let's go ahead and subtract. Okay, and I just did that and I got 29.85. Okay, so let's write that down. 29.85. So what we're checking for now Is 2985 going to include all of our data, or do we need to subtract one more standard deviation? So this is, we subtracted 36, which was one standard deviation. Okay? And I see I have 2560. Okay? And that's below 2985. So if I subtract 36 again, we're going to be below that 2560, but we have to. We can't subtract. It has to be a whole number. Standard deviation. Read that problem. How many standard deviations from the mean do the prices fall? Determine the whole number of standard deviations. We have to go one more. So we've gone down 1, 2 standard deviations from the mean. Okay? And we've covered everything below 65.85. We've got to go this upwards, and we have to go up until we've hit our highest, which is 126.40. Here's our lowest. We hit that. Now, we might need to, obviously we have to add to go upwards from that 65.85. Oh dear, that's a 3. That's a 6. 36. So we're going to take 65.85 and add 36. That gets us to 101.85. Now, if we have to go with however many is the highest number. So basically, worst case scenario, how many standard deviations do we need to go from our mean to hit all of our data? 101.85. The heck? There we go. Okay, so then we're going to have to add 36 again, and that's going to take us above that 126, thank goodness. That's going to take us to 137.85. So I'm not going to write it. My hands are not working on this trackpad. So as I said, add 36 again, and that takes us to there we go, 37, spoke too soon, 85. Oh my goodness. Alright, use your imagination. That is a 36. So we would have to say we have to go 2 below and 2 above. If we had to go 2 below and only 1 above, we'd still have to say that it took 2 standard deviations to get to that lowest number. So we had to use 2 standard deviations from the mean to get all of our prices. So when it asks a question like that, within how many standard deviations of the mean do all of the prices fall, you would have to say 2. That would be our answer. 2 standard deviations. All right. This last question we'll talk about, how is your standard deviation similar to range and interquartile range? Let's touch back on that. So we had said that so far this year we've talked about measures of center, like mean, median, and mode. These are not measures of center. These are measures that tell us how spread out our data is. So we use mean, median, and modes to see what our data is centered around. We use measures of variation, like variance and standard deviation, to see how spread out that data is. So just like we did here, we use that mean, 65.85, to see how many standard deviations, so that would be like our center of our data for this problem, and then we can see that all of our data is enclosed within 2 standard deviations of that mean. So if we were to add or subtract 36 twice, we would get all of that data. Or if we were to subtract 72 or add 72, we would have all of our book prices. So how are they similar? How are they different? We use them to compare data. We use them to compare different sets of data, but they're different because range and interquartile range are just like those measures of variation, just like we did standard deviation. This tells us how close, mean, median, mode tells us how close together our data is. Standard deviation and range and interquartile range tell us how spread out that data is. So that's how they're similar. They all three talk about spread. Okay. So you have a homework assignment. Let me just double check. This Yeah, this should be great. It's matching what's on the board and also what's in Google Docs. Um, so go ahead, give it a try. If you have questions on it, make sure you're checking the teacher book. And we will talk about those tomorrow, and we'll kind of have a catch-up day tomorrow to work on questions, makeup work, all kinds of stuff like that. So have a great afternoon.